Okay. All right, so continuity. We've kind of already talked about continuity. You guys have seen pictures like this before on graphs when we're talking about limits, right? When we're trying to find a limit, we've looked at pictures of graphs like this, right? Well, now we're going to give them names in terms of discontinuity. So there's 3 types of discontinuity. The first one is a hole. It's called removable discontinuity. Okay, removable discontinuity. It's when a hole happens, right? So we would say it's discontinuous at whatever point that is. So whatever x value, we'll say a, at a, it's discontinuous. Does it have a limit? Yes, at a, it does. It does have a limit at a, right? It meets, but there's no value there, okay? So that we call that removable, right? The next one is called non-removable, or sometimes they'll call it infinite discontinuity. That's the same thing. It's when we have a vertical asymptote. When we have a vertical asymptote, we have discontinuity. Okay, not horizontal. Horizontal is not what we're talking about here. This one's just vertical. All right. So when does this happen? When there's a value that makes the bottom 0, right? If I have a equation like this, 1 over x plus 2, right? It's going to have this kind of discontinuity, vertical asymptote, non-removable, at -2. Because if I plug in -2, I get 0, right? I get 0. Can't have 0 on the bottom. Okay. And then the last one is called it's a form of non-removable, but it's also called jump discontinuity. That's the name that we call it most often, jump discontinuity. There's a disconnect. It kind of picks up. It jumps. It almost jumps. Like at, let's see here, at this value here, at A. So if we were to follow along, it stops up here and then it starts up back here. It jumps. It kind of makes a jump. There's a gap in discontinuity there. That is called non-removable, but it's also called jump discontinuity. Okay. It's also no limit. The limit does not exist at A because they meet at different spots. Okay. All right. So those are the 3 types. So when is something continuous? Well, there's continuity if the limit at a point equals the value, the number at a point. So I kind of wrote it up here. It's also right here too. The limit as x approaches a number from the left, if that's equal to the limit as it approaches from the right, if they meet at the same y value, there's a limit there, right? Well, if that number is also equal to the answer, there, right? So that's where it's different than some of these. Let's look at this guy. This one has a limit at A, right? It has a limit. Problem is, it doesn't fulfill this one here. Because is that limit also the answer at A? No, it's got a dot. It's got a hole, no dot. If that was a dot, then it'd be okay, right? So it has to have a limit there. It has to have a limit at that, and the limit has to equal the answer, the y value, right? When I plug it in, it's got to have there, right? That's why these guys don't fulfill that, right? This one doesn't even have a limit at A. The limit doesn't exist. So this limit from the left, this limit from the right, or sorry, from the right and from the left, they don't equal the same number. Okay, so the limit has to equal the answer. That's how we know there's discontinuity. Okay? So for there to be a limit, though, it has to be approaching the same y value from the positive side and from the negative side. That just means they meet at the same y value. And I can't have a hole there. I have to have a dot. If that's true, then it's continuous. If that's not true, then it's not continuous. Okay? Okay, so let's look at some pictures first. Let's look at some graphs first. So the first one is a graph from 0 to 5. From 0 to 5. X equals 0 to x equals 5, in between there. Okay? So the first thing they want us to do is find where it's continuous and where it's not continuous. All right, where is it continuous and where is it not continuous? 1 second. Okay. Okay, so on the graph, let's start with 0. X equals 0. So x equals 0, we start here, right? And then we run into our first issue with continuity, right? What type of continuity, what type of discontinuity is that x equals 1? It's a hole in the graph, right? So what is that called? Removable discontinuity. Okay? So we're going to have two lists here. We're going to have two lists. We're going to have a list of continuity and a list for discontinuity. So continuity, continuous, discontinuous. So where is it continuous and where is it discontinuous? So we know it's discontinuous at x equals 1. And we said that's removable. Discontinuity. Okay. Where else is it discontinuous? So let's keep going. It looks like I jumped from over here to over here. So what's happening at 2? So it's non-removable. Is it jump or is it infinite discontinuity? Infinite, right? There's an asymptote there. There's a line at 2 that it doesn't cross. So it's, like you guys said, it's non-removable. It's non-removable, but it's also called infinite. So either one, non-removable / infinite. Okay. So let's keep going. Where else is it? Looks like at x equals 4, right? At x equals 4 is also discontinuous. Also non-removable, but jump, yeah. So we would say non-removable / jump discontinuity. Okay? So that's where it's discontinuous. That's where it's not continuous. At 1, at 2, and at 4. My next question is, then where is it continuous? So it's continuous at 3. Where else? 0. So it's discontinuous, or sorry, it's continuous everywhere there's green, right? So we're not going to list all of those because there's an infinite, even between. So even from here. How many points are on that segment there? Yeah, an infinite number, right? An infinite number is too many to write. So instead of saying listing all of them, we can write it as an interval. We'll write it as an interval. So we would say starts at 0 and goes to 1. That means everywhere from 0 to 1. So you guys know the difference between the brackets and the parentheses. So there's two types. There's this 0 to 1, and then there's 0 to 1 with brackets. What's the difference? What's the difference between parentheses and brackets? Yeah. So if we want to include 0 and 1, we use the brackets. If we want to just say everything between 0 and 1, we use the parentheses. So which one are we going to use? How do you know? Well, we go back to the question. Which one did the question use? Do we include 0 and 5 here? Did they include it? No, they didn't. How do I know they didn't include 0 and 5? The equal, right? There's no equal signs. If there was equal signs underneath here, if there were equal signs, if it said this, right? Then it would include, then we need brackets, but they usually don't have those. And I don't want to include 1. Why don't I want to include 1 with a bracket? Because it's discontinuous, we said. So we want to just say everything in between 0 to 1. That's why I use parentheses. That's why I use parentheses. Okay, that's one interval. We're going to use kind of a U shape. It's called OR. It's a union. It's an OR. So that one, or where else? Where else do we pick up? 1 to 2. Yeah, 1 to 2. 1 to 2. We're not going to include 1. We're not going to include 2 because that's where discontinuity happens. Okay. Or where does it pick up after that? 2 to 4. Yeah, 2 to 4. And then the last one, 4 to 5. 4 to 5, and we're home. We're done. So every part from 0 to 5 we've taken care of. Every number from 0 to 5 we've taken care of. We've said everywhere between 0 and 1, 1 and 2, 2 and 4, 4 and 5 is continuous. Where is it not continuous? At 1, 2, and 4. So there's no parts of that are not taken care of. Okay? All right, so flip it over. Let's see. What we have to do here is figure out for when C equals 1, 2, and 3, or sorry, 1, 2, and 4, it's the same graph that you guys saw in the front. Find the limit from the left, find the limit from the right, and find the overall limit. Okay? So what we're going to do is at 1. So let's start at x equals 1. So we're going to write the limit as x approaches 1 from the left for f of x. The limit as x approaches 1 from the right for f of x. And then the limit as x approaches 1 overall. I'm going to find the answer to all of those. If they're equal, great. If they're not, then there's no limit, right? Oh, sorry, and then f of c, sorry. I forgot to include that one. We're going to include one more. I'm going to make this smaller so I can include it. Okay. If all of these are equal, it's continuous. If one of them does not equal, as soon as one of them doesn't equal each other, the rest, it's not continuous. Game over. So this is what we call the definition. In math, we have definitions, but they're usually not word definitions. This is what we call the definition of continuity. If all 4 of these guys are equal, it's continuous. If one of them or more than one of them doesn't equal, then it's not continuous. So let's go look at this. So let's look at 1. So from the left side, from the negative side, what is the limit as x approaches 1? 1. Okay, so we're going to go put that down. Okay. What is the limit as x approaches 1 from the right side? Also 1. Okay, we're doing good so far. So what's the overall limit at 1? 1. Good. So what is f of 1? 3. There's where we go. There's where that one doesn't work. So that's why we already know it's discontinuous at 1, right? We said that earlier. We said that for example number 1, right? We said it's not continuous or discontinuous at 1, right? That's the reason why. Because that guy does not equal 1. Right? Okay, so let's do this again for now 2 now. Let's do it for 2. The limit as x approaches 2 from the left. The limit as x approaches 2 from the right. The overall limit. And then f of 2. Okay. Remember, there's an asymptote at x equals 2. We said that on example number 1. So what is the limit as x approaches 2 from the negative side? From the negative side, where is it approaching? Not to positive infinity. It's approaching positive infinity from there. So we say positive infinity. How about from the positive side? Positive infinity, right? What is the overall limit at 2? Doesn't exist. Yeah, it does not exist because infinity is not a number. Even though they are both approaching positive infinity, infinity is not a number. Those two numbers have to be equal for them to have a limit. So what is the answer at 2? Yeah, undefined. There is no answer at 2 because there's an asymptote there. There's an asymptote there. So that's why, because those guys don't equal each other, is why it's called the definition. This is the definition of continuity. Okay? All right, so now I want you to do it for the last one. Do it for 4. So the limit as x approaches 4 from the left, the limit as x approaches 4 from the right, the overall limit, and then f of 4. We know at least one of them won't equal each other because it's not continuous. Which one will it be? Or which ones will it be? Okay, so the limit as x approaches 4 from the left is 2. It's approaching y equals 2. The limit as x approaches 4 from the right, though, is not 2. It's positive 1. Which means the overall limit does not exist because those two don't equal each other. And then one of those is the answer. Which one is the answer at 4? What? So because those guys don't equal each other, that's why it doesn't exist. So the reason it's important is because when they ask you to justify your answer, this is justification here. This is why It's not continuous at 1, not continuous at 2, not continuous at 4. This is justification, okay? Because when they ask you for justification, it's important, okay? Okay, so here we're going to move to what we most likely see. Most of the time, we don't get a picture. When we're trying to decide continuity, we don't get a nice, pretty picture. So you don't always get a picture, so you will have to be able to do this algebraically as well. Determine whether each function is continuous or not continuous. Use the definition. Okay, so I want you to look at A. So theoretically, we have to check every x value from negative infinity to positive infinity, but that's literally an infinite number of possibilities. So let's focus in on what might be a problem. So looking at 3a, which x value is going to be a problem for continuity here? 1. Yeah, why 1? Yeah, 1. If I plug in 1 for x, that's going to be an issue because I'm going to get 0 on the bottom. I'll have a number over 0 that's in vertical asymptote, right? We know that, but we need to use the definition to prove it. Okay, so here we go. So I know there's a picture. I know I'm going to try to put a picture in my head. I know this guy is going to look like this. At positive 1, there's a vertical asymptote. I know that. Okay, we know that because we've done finding vertical asymptotes. There's no other number I can plug in for x that's going to give me 0 on the bottom. So the only value I need to check is x equals 1. So what I'm going to do is I'm going to use the definition. The definition says find the limit as x approaches 1 from the left. Find the limit as x approaches 1 from the right. Find the overall limit as x approaches 1. And then find that guy. Oops, not C, 1. If they all equal each other, it's continuous at 1. Okay. Oops, I forgot to put 1 here. Which one's probably there's some that are easier to answer than others. Which one's probably the easiest one to answer out of all 4 of these guys? The third one, right? We know it's discontinuous. We know that either it's going to go this way, it's going to go this way, or we know it's going to look like one of these guys. So we know that this guy is not going to exist. We know that guy is not going to exist. We just know. What's the solution at 1? How do I get the solution at 1 without a picture? Plug it in. What happens when I plug in 1? I get undefined, right? That's enough. You don't need to show these guys anymore. Oops. I don't need to answer this guy here or here because I already know that these two aren't going to equal. These guys aren't equal. There has to be a number where they're equal to each other. These guys are meaningless. It doesn't matter what these guys are here. These guys don't matter because I'm already done. I've already shown that they can't be continuous. So we're going to say not continuous at x equals 1. That's my explanation right here. This is my explanation right here. This is my justification. So it says explain why. That's right there. Those guys don't equal each other. I'm not even going to waste my time figuring these out because I've already know that D and E and undefined are not the same thing, right? If these two are the same thing, then I would go here and here to see if those two equaled each other too. Okay. All right, so here we go. Let's look at B. What's the only value here that we might have issues with? -2, right? -2 is the only value that I might have issues with continuity. So that's what I'm going to check. Okay. Sorry, yeah, -2, yep. Yep. So if I plug in -2, I already know what I'm going to get. Undefined. I know I'm going to get undefined. And what am I going to get at the limit as x approaches -2? I'm going to get D and E, right? Because there's an asymptote there. There's an asymptote here. So again, it doesn't even matter what the other two equal because there's no way they can equal each other. So we're going to say not continuous at x equals -2. Okay. Okay. So let's look at the next one, letter C. Letter C is a piecewise function. It's got two pieces to it. Okay. These are the ones that you're going to see most often. Piecewise. They're big. One of the big things they do on multiple choice and free response is they want you to find continuity or discontinuity. Is it continuous? And they'll give you piecewise functions. Okay. Where is the only... So again, I don't want to have to check from negative infinity to positive infinity. Let's zero in. Which are the value or values that I might have an issue with continuity? Yeah, why positive? Positive 1, definitely. Why 1? Because that's where they do what? That's where they switch. That's where they change, right? So before 1, it's linear, straight line. Okay. After 1, at 1, and then it's a parabola, right? Straight lines don't have any issues with continuity. Straight lines just go on forever and ever and ever. Same thing with parabolas. So the only place that I would have to check, is at 1. So what I'm going to do is I'm going to set up my problem again. The limit as x approaches 1 from the left for h of x has to equal the limit as x approaches 1 from the right for h of x, which equals the overall limit, which equals h of 1. Okay. So Let's start with the limit as x approaches 1 from the left. Which one, how am I going to get this answer? So how am I going to get this answer here? Yeah, plug in 1 to the top equation, because that's the one less than 1, right? From the left means less than 1. So I'm going to plug in 1 to the top equation and see what I get. So -2 times 1 plus 3. -2 plus 3, so I get +1. Okay, how do I get the limit from the right side? Plug in 1 to the other one, to the greater than 1. 1 squared equals 1. So far, so good. How do I get the overall limit? Even easier than that. You could do that, but even easier than that. If they're the same number, that's also going to be here too. If they're not the same number, if these two guys right here are the same number, then the limit has to equal that number. If they're not the same number, it's D and E. But they are the same number. So, 1. Last step. So far, so good. We got 1, 1, and 1. How do I find the solution at 1? Well, yeah, but how do we have this? How do we find the solution? We do actually, but how do we find the solution at 1? We're going to do what we did earlier, right? We're going to plug in 1, but where? To the top or bottom? Bottom, which we already did. So all 4 of these guys are equal. Because all 4 of these guys are equal, we would say h of x is continuous everywhere. This is our justification up here. Our justification is up here. That's why we can make this statement. The reason we can make this statement is because of our justification. Okay, I'm going to give you a problem to do like this on your own, because these are big. These are big problems that you're going to see, like piecewise functions. Okay, so try to find some space either on that page or later on, like in the back or something. We'll call this letter C. Okay, so f of x. So you're finding checking continuity everywhere. So you get -2x x squared minus 4x plus 1. And okay. Double check I did that right. Okay. Check continuity everywhere. See if there's any discontinuity anywhere. Use the definition. Make sure those 4 things are equal to each other. The only place that we would have issues is at 2. Because before 2, or at 2 and before is linear, -2x. After 2 is quadratic, it's a parabola. No issues with continuity there. So 2 from the left, we're going to use the top. So it's going to be negative 2 times 2, which is negative 4. 2 from the right, we're going to use the bottom. So 2 squared minus 4 times 2 plus 1. That's 4 minus 8 plus 1. So you get negative 4, negative 3. Because those two guys are not the same, they're close, right? They're very, 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 very close, but they're not the same. Because those two guys are not the same, we say D and E. Because those two guys are not the same. F of 2, we would plug into the top, which we did earlier, so that would be negative 4, right? So if this guy right here was negative 4, it would have been continuous. But because this guy is a negative 3, it's not continuous. So we would say f of x is not continuous, or you can say discontinuous, at x equals 2. Okay. Let me see if I can give you another one. I don't want to go on because we're running low on time, but we got enough for one more. So I'm going to try to find one more to give you. How about this one? Letter D. Okay. Last one for today. So this one's a natural log. Natural log on top, quadratic on the bottom. The first one from the left, you plug it into the bottom, you get 1, because 1 minus 0 squared is 1. From the right, I plug in 0 and I get the natural log of 1. What is the natural log of 1? What is the power that makes the overall answer 1? 0. That's what it's asking. What power do I give that would make 0? That would make 1 the answer, 0. So these two are not equal. This one's just 0 too, so they're not equal. So we say discontinuous or not continuous at x equals 0. All right, there's a jump. There's a jump continuity because they're not equal to the same y. There's a jump at 0. Okay. All righty, guys, we'll continue